Alrighty, let's talk about characteristics of our sun. So the sun is obviously very, very hot. It's about 15 million degrees Celsius. No, you cannot land on it. You would burn to death way before you got there. But the sun is very useful, as are all stars, because it is the very reason that we are alive and have heat and light on Earth. The sun is the only star in our solar system. There are some systems where you can have multiple stars, or where even you'll have two stars that rotate around each other, but our solar system just has one, and our sun is considered a yellow dwarf star. So as you compare different stars, you have some that are a lot bigger than ours and some that are smaller. So we're kind of in the average range in terms of size and temperature compared to other stars. And there are different parts of our star. You have the photosphere, which is the surface of our sun, and it makes the light, and it's the most prominent layer. It's basically what you see when you look at it, even though you're not supposed to look at the sun. There is a picture of it with all of the extra light and gases kind of erased off of it. That is what it looks like. And then right after that, you have the chromosphere. This is like the really pretty halo that you can see during a solar eclipse when the moon goes in front of the sun. That is what it looks like in real life. Again, like a really pretty little halo thing. And then you have the corona. This is the outermost layer of gases surrounding the sun. And again, it can only be seen during a solar eclipse when the moon is blocking out everything else. And instead of just a little halo, it's really, really wispy, as we can see in this right picture here. So you can see all the little wispies. So those are the main three parts of the sun. And then you also have the solar winds. So if you've ever heard of the northern lights, solar winds coming off of the sun is what causes those. So you have all these electrical particles coming off of the sun, and when they hit our atmosphere, they do funky things to the lights, and that's what causes that glowing stuff. They are called the aurora borealis in science. I would know the term aurora borealis and not just northern lights. That's what they look like in real life. Again, very pretty. And then you also have sunspots. These are dark spots on the surface of the sun where the temperature is lower than the surrounding areas and they don't give off that much light compared to the other parts. So that one is pretty self-explanatory. That's what they look like on the surface. And then you have these things called prominences. So these usually happen near sunspots, and these are giant looping explosions. The key word here is looping, because you have solar flares, and these are explosions that do not loop. Typically, it's when prominences connect, and they shoot off kind of like a giant volcano. And these ones can actually be dangerous depending on how big they are. They can create a lot of solar wind that can mess with communications here on Earth. So these ones can be dangerous, more so than a regular prominence, but that is what they would look like. And then going back to the prominences, these are what the prominences look like. Again, the prominences are loopy, the solar flares are not loopy. All right, that's pretty much it in terms of what you need to know about stars, but I'll go ahead and talk about a little bit more about how stars are formed, because it's cool. So again, going back to the Big Bang Theory, when everything was first forming, you have little bits of stuff clumping together, gaining more gravity and stuff. Stars are giant clumps of gas, basically. And what happens is that a star gains so much mass that the gravity starts to do nuclear fusion in their core. So nuclear fusion is when you take two atoms and you fuse them together into a bigger atom. So most stars are mostly made of hydrogen and helium, and hydrogen has one proton in its nucleus. Helium has two. So in the cores of most stars, you take two hydrogen atoms, you fuse them together, and you get a helium atom. And that nuclear fusion is what creates all of that light and heat that gives stars their energy. And depending on the type of star, once that nuclear fusion runs out of fuel, the star begins to die, or it can do fusion with other things. And then, of course, depending on how big the star is and where it is in its lifetime, it'll either die in this giant explosion, or it'll collapse in on itself, or it could even turn into a different type of star or a black hole. It depends. Again, you don't need to know this for your test, but it's just cool.